This video is the second part for confidence interval for proportions, and we will be concentrating on the sample size in this video, how to estimate the sample size. So if you know that you want to be 95% confident, how big sample you should choose if you want to have a margin of error of 2% or margin of error of 10% or margin of error of 5%. So earlier we saw the margin of error formula. That was E equals in the last video Z alpha over 2 square root of P hat Q hat divided by N. So from this equation, if we try to isolate the N, then isolate N. So we would have to do square both sides first and then shuffle things around to isolate the N. We would get to this point. So that's the formula to find out the sample size. If you know how large of margin of error do you want a smaller margin of error, larger margin of error? So estimating a sample size here. Here's a formula for the sample size, which is obtained by solving the maximum error of estimate formula for the population proportion for N. Some texts use P hat Q hat, some use P and Q. It doesn't really matter. Ours use P hat Q hat. P and Q, or P hat and Q hat, are taken from a previous study if one is available. If there's no previous study or estimate available, then use 0.5 for P and 0.5 for Q, as these are the values which will give the largest sample size. And it's better to have too large of a sample size and come under the maximum error of estimate than to have too small of a sample size and exceed the maximum error of margin of error or maximum error of estimate. Okay, so here's the formula we will be using to estimate the sample size. Suppose we desire, example number 5, suppose we desire to determine the percentage of US adults who use the internet. How many adults must be surveyed in order to be 95% confident? So we will be given in the problem the confidence level, because that decides our Z alpha over 2. But if confidence level is not given, then by default, 95% is the confidence level. So we want to be 95% confident, and we want the margin of error to be no more than 3%. So we don't want to have margin of error more than 3% and 95% confident. So formula here is for N, it is Z alpha over 2 squared, and then P hat Q hat divided by E squared. Or there's different ways of writing it, expressing it the same thing. We can write Z alpha 2 over E squared times P hat Q hat, same thing. Now Z alpha over 2 comes from your confidence level. For 95% confidence level, Z alpha over 2 is 1.96. We want the margin of error to be 0.03. And P hat and Q hat, do we know these from the previous study? Looks like we don't. If we don't know P hat and Q hat from the previous study, we would use 0.5 for P hat, 0.5 for Q hat. We just assume that 50% of the people said in one direction and 50% of the people said in other direction. That's what 0.5 for P hat, 0.5 for Q hat mean. And when we simplify, that turns out to be 1067.11. Now, one thing that's really important, anytime you're estimating a sample size number of people, if you get a fraction, always round up. Always round up, no matter if it's, don't round to the closest number, because don't follow the rounding rules, because if you follow the rounding rules, you would round it to 1067. But just to make sure that you fall under the margin of error, we want to get the largest possible sample. So always round up. We don't want to have fraction of people. We don't want to have 10 people and one arm or something like that. So 1,068 people is what I would survey if I want to be 95% confident and I want to have 3% margin of error. Okay, 95% confident and 3% margin of error. All right. Next example, number 6. Estimate the sample size given the confidence level is 90% and margin of error is 5%. So for confidence level 90%, we do have Z alpha over 2. We found these in the last videos as well. Z alpha 2 is 1.645. So we have 90% area in the middle, and we're looking for the z-score that has 0.05 area in one tail, 0.05 area to the right. So that is 1.645. And the margin of error is 0.05 because it's 5%. To change 5% to decimal, we have the decimal here, we move it 2 places to the left, 0.05 or 0.05. Now, to estimate the sample size, in first part which says we know nothing about the population, so we don't really know p hat, q hat, or pq from the previous studies. That means we're just going to assume p hat is 0.5 and q hat is 0.5. N is equal to z alpha over 2 divided by e squared p hat q hat. Now, z alpha over 2 is 1.645. Margin of error is 0.05. Square everything. P hat is 0.05. Q hat is not 0.05. It's 0.5 and 0.5. So 0.5 and 0.5. And that turns out to be 270.6. So we would estimate 270, we would survey 271 people. Always round up, okay? 271 people. So if we know nothing about the population, we want to be 90% confident about something, and we want to have 5% margin of error, we would estimate 271 people. Okay? Now in the next case, I actually know p hat. So let's say from a previous study, I know p hat. So still, we want to be 90% confident. Confidence level is still 90%. It's a part B for the same problem. Margin of error is 0.05. Z alpha over 2 is 1.645. So now the sample size, let's see how does the sample size get affected. We know p hat and q hat in this case. P hat is given to me. P hat is 0.85. Q hat is not given, but we know q hat is 1 minus p hat, and that's going to be 0.15. So 0.15. So let's go ahead and plug everything into the formula. We have 1.645 divided by margin of error 0.05 squared 0.85 and 0.15. That turns out to be 138.07. So we would have to survey 139 people. So if you know something from the previous population, or your p hat is bigger than 0.5, then looks like I would have to survey fewer people to be able to be same level of confidence and to have the same margin of error. Okay? That was examples about estimating the sample size. Now, let's look at a couple more estimating the sample size. Sample size. So here's example number 4. An urban economist wishes to estimate the proportion of Americans who own their house. What sample size should be obtained if he wishes to estimate to be within 0.02 with 90% confidence level? So he wants to have 90% confidence level, and he wants to have a margin of error of 0.02, which is 2%. So 0.02 is the margin of error. And confidence level is 90%. Z alpha over 2, critical value for confidence level of 90% is 1.645. So N turns out to be Z alpha over 2 over E square P hat Q hat. In part A, he does know, he uses an estimate of 0.75 from the previous quarter data. So he has the previous sample data that the P hat is 0.675. So N turns out to be 1.645 divided by 0.02 squared. P hat is 0.675. Q hat would be 1 minus 0.675, which is 0.325. And that is, so I'll leave the calculation part for you. Always round up. So that's how many people we would have to survey to be able to estimate the proportion of Americans who own the house if we want to be 90% confident. For part B, says he does not know anything from the previous studies. There's no prior estimates available. He doesn't know what proportion of Americans owned house or what proportion of Americans owned their house from the previous studies. He has no information available. So in that case, the only thing that changes is our P hat and Q hat. We just assume that 50% of the people owned their house, other 50% did not, because we don't know that information. So that turns out to be 1.645, same. Z-score, the margin of error is not changing. The only thing that change is the P hat and Q hat. And again, go ahead and simplify it. Don't forget to round up, and that would be our estimated number of people. Okay, round up, that would be our estimated number of people. And that's all for our sample size. And in this section, we looked at constructing a confidence interval for proportions, as well as estimating a sample size when we're dealing with proportions